So, factors are two numbers multiplied to get another number. What we're going to be doing today are things like this. We are going to be doing things like the cube root of 243. And that's not something, well, that's only like one tip of the iceberg of what we're doing.
You're definitely getting squirrels.
71.
We're getting two squirrels.
Knock it off. It's over. This is not something you can just punch into the calculator. What you're going to have to do is, and here's where I'm going to have improved on this method from Monday. Here's the best and easiest way to find the cube root of 243 because I do not want a decimal. What you want to do is form a factor tree, which I know you've probably done in pre-algebra, but we're doing it again now. So, 243. You need to find just one factor of 243, and the way to do that is have a calculator, although most of mine are gone today with that test. What is a number that divides evenly into 243?
71.
No, it doesn't. Try 3. What about just 3? We'll do it. 81. 243 factors into 3 and 81. What does 81 factor down into? Now 3 is prime, so 9 and 9. What does 9 factor into?
3 times 3.
Shh. Now, here are all of our prime numbers. We just factor 243 into 3 times 3 times 3 times 3 times 3 to the 5th. Now, if we were to put these three together, it'd be 3 to the 3rd, and if we put these two together, it'd be 3 squared. Why is he doing it like that? Because this problem was originally the cube root of 243, which basically means you need to find numbers that are perfect cubes, because cubes and cube roots cancel, as do squares and square roots, and fourth roots. So, those cancel.
What would happen if you tried to put that in the calculator?
It would give you a decimal. You could do it. You would just do 243 to the 1/3 power, cube root. So the 3 comes out. Now notice, the 3 squared. Didn't we have 2 3s that didn't form a full group of 3? These did not have enough. The 3 squared did not have the required number to come out. So they just hang tight. What is 3 squared? 9. So the cube root of 243 is 3 times the cube root of 9.
Like 3 times 3 is
No. Oh, well, those two, yes. Yes, those two, yes. So, cube root of 243 is 3 times the cube root of 9. You're going to have to factor things, find the ones that have the correct number from the index. That number is called an index, apparently. Somebody told me that the other day. And then that can come out. Let's look at another one. If it sounds...
Hold up. Explain to me why you took the 3 cubed out of that equation right there.
Okay, I will explain that. That's a good question. Everything in math has a counterpart. Plus 3, minus 3, times 3, divided by 3, etc. A cube, its counterpart is a cube root. They undo each other. So really, they canceled and this came out. That's what happens. Good question. Now, let's look at another.
If the other one been like 3 cubed times 3 cubed.
Then they both would have come out, and 2 3s would have come out. You're looking for groups
6
of...
cubed on the outside? Or was
No, it would be 1 3 came out, another 3 came out, and you'd multiply them, and it would just be 9. Let's look at one like that.
So
Let's look at one like that.
9 times the cube root of...
Yeah. How about this? Let's take the 4th root. See, it's not just going to be cube roots today. The 4th root of... What is 16 times 81, Mark? 16 times 81. 1,000. We're going to find the 4th root of 1,296. Now, you won't have one this big today, but the point is to look at the question that TJ asked me. So, you have to factor 12,096. Now, because Mark just told me that it was 16 times 81, I know that factors into 16 and 81. What does 16 factor into? 4 times 4. What does the 81 factor into? What do the 4s factor into? Now, look at your index. I'm looking for numbers that occur this many times. What numbers occur 4 times at the bottom there? 2 and 3, which means I'm really looking at this. 2 to the 4th and 3 to the 4th. And everything that has the proper number from the index can come out. So, cancel, cancel, 2, cancel, cancel, 3, and there's nothing even left in there. They all came away. So the answer, the whole 4th root of 1296 would just be 6. You factor it and you look for things that have that same number. And then if they occur that many times, you can take them out of the root. Yes, sir. Yes, I do. Do you have something you can give me as collateral for my pencil? All right, then. You can walk that boot up here and put it under my table here. There you go. All right. Now, let's look at another one. I want you to try to do this one. Just try to do this one. How about the 5th root of 64? Factor down 64 as far as you can. Okay. 5th root of 64. That's what you need to start doing now. You just need to be factoring that as many times as you can. It is not 64 divided by 5. It is nothing like that. You have to factor the 64 as far as you can. Unfortunately, that is the easiest way to do it.
I didn't think it was too hard, but it was kind of simple, but I guess it's going to be hard when we do it.
Well, this is what you'll be doing. Do it.
How we going to do it right now?
2 to the 6.
Is it a 3?
That's the 5th root of 64.
Why? We have to curse it in math.
Ashley, you found my thingy yet? Ashley, what does this factor into? That's why I was asking.
You said you found your thing.
I meant, have you found a factor of 64 yet? Thank you, Kagan. What a perfectly
Actually,
wonderful answer. Kagan says 8 times 8, and a very proper way to answer my question. 8 times 8.
I used 4 and 16.
That's fine. That's fine. You should still get the same thing. What does 8 factor into?
4 and then 2.
Very good. Now, can you factor the 2's? No, they're prime.
Circle.
Okay, that's a good idea. Go ahead and circle them when they're prime. What do I do with the 4's now?
Yeah, 2, 2.
Cody, you're all over this.
Yeah.
But you're not writing any of this down, are you? Which means later when we do it, you're like, what do I do? Even though you know what to do. But you're not writing it down. So, I'm looking for something that I have 5 of. How many 2's do I have? 6. I take one group of 5 of those 2's out because I needed 5. So one group of 5 comes out.
2 to the 5th and then 2 to the 1.
Well, really it's just like this. It's not 2 to the 5th because you need 5 to come out.
Yeah, I see it.
And then you had 1 left because there were 6 total.
They stick it
So
in.
that stays in there. Exactly.
Got it.
Exactly. That's the hardest part of what we're doing today.
You serious?
We are throwing something else in there, but that's the hardest part. Now, what if at the very beginning I had said 3 times the cube root of 5th root of 64? That doesn't change anything. You still work the whole thing the exact same way, but at the end you would multiply by 3. I don't know why that didn't show up here.
There it is going up or slowly.
What is going on?
They just kind of like move. There it is, there it is.
Yay!
That's crazy.
So,
man.
if I did 3 times the 5th root of 64, then at the end I would do 3 times that, and that would be 6 times the 5th root of 2. If there is a number on the outside, you're not going to do a single thing with it until you're done. Then you'll just say, oh, by the way, times that number. Now, here's where all this is going. We're going to be doing things like this. Now, this is a very straightforward example because it's just a square root of a number we can probably do in our heads. What's the square root of 16? 4. Now, that's much easier than the ones we've been doing, but we are going to get back to those hard ones. The square root of 16 is 4. Now, for the letters, believe it or not, are the easiest part of this. The easiest part of this. How many, okay, think of it like this.
Why'd you put that 2 there?
Because a square root, if there's no number, you assume it's a 2. Okay, think about it like this. If you had 8 people show up to something, imagine there were 8 of you in here, and I said, get in groups of 2. How many groups are we going to make?
4.
That is how this is going to work. You need to find as many groups of 2 out of 8 that you can. And there were 4, right? And if we had 4 groups of 2, how many people wouldn't be in a group? None. So 4 groups of 2.
At 7, you just messed up everything.
No, we're not. 4 groups of 2, none were left in here. I used all 8 of them. Now, if we had 7 people, how many groups of 2 would we have?
3.
But how many people wouldn't be in a group? So, 3 groups of 2, and there'd be 1 person left. Because it didn't have enough to come out. And that's what we're doing. The exponents are really the easiest part.
If it comes out evenly, you don't put anything.
What is that?
That's right. That's right.
Wait a minute, you got Q, 2, what? Q cubed,
Because I had 3 groups of 2 cubes.
yeah, and then you had the extra Q.
Because it was an odd number.
Oh.
Bless you. Question. Bless you again. Question. What is it about this class and people having... Oh, you seniors weren't here that day. Oh, I'm going to have to let them hear that video, Mark. I have a treat for you seniors. Something really funny happened on Monday. We'll get to it in a minute.
squirrel.
Okay. Sure. Now, here we go. We're going to do a more complicated example. All right. Shh. Not until he gets back. All right. We are now going to do the 4th root of, let's call it 162 times q to the 7th p to the 11th. Now, I like to do my variables first. My variables first. How many groups of 4 can I make of 7?
3 and now 1 left over.
You got that backwards. You can make 1 group and have 3 left over. Yeah. So, 1 group of 4 and then 3 left over. Now, a way to check this is just take your exponent and be like, hey, that was 1 times 4, so I took out 4 of 7, and then just subtract. 7 minus that 4 leaves you with 3.
And then you got 5 and 1.
Not quite. You can't make 5 groups of 4. You're thinking if it was a square root. That's a 4th root. 2 groups of 4. And if I had 2 groups of 4, how many are going to be left? Very good. Very, very good. 2 groups of 4 made 8 total. 8 of the 11 left you with 3. Now we have to do the number, and you cannot do it the same way. For some reason, when we put these 2 things together, people have mental train wrecks.
Hey.
You just go back and do the numbers the same way we did them a second ago. Factor it. 162 factors into 2 times 81. 81 goes into 9 and 9. That's right, 9 and 9 go into 3, 3, 3, and 3. Is there a number that occurs that many times? 3. So I can pull a 3 out, so it'll be 3. And what number does not occur that many times? So the 2 stays in. And that bottom thing right there is your answer.
Don't need those special.
The one I circled. Because the 3 occurred 4 times, it comes out. And the 2, because it didn't occur 4 times, stays in. For the sophomores who were here the other day, how much smoother is this lesson than the one we had on Monday? A lot. We didn't actually do it by the factoring, but this is going a lot better. So you guys are in luck. Yeah, it really is. What we did on Monday was much more complicated. Yes, sir.
How did you get, oh, never mind. Yeah,
I kinda
how'd
like
you
it
get
the other
a
way
cube,
better.
how you get the,
Well, that's why
like
you
the
do
cube
those.
three and the E cube?
Right here?
Yeah, how'd you
How many groups of 4 could I make of 7?
get two?
1. So if we had 7, imagine you were playing basketball, there are 7 people. How many teams of 4 could you make? Just 1, right? 1 group of 4, and then how many people wouldn't have enough for a team? 3. If you had 11 people, you could make 2 teams of 4, and you'd still have 3 people sitting out. That's where that came from.
With basketball, you're gonna have 5.
Unless it's half court. Man, 2-on-2 full court would be exhausting. Anyway, questions?
Yes, it would.
If I had a 4 out here, if I had said 4 times all this, you still work it the same way, and at the very end, you'd multiply it by 4. So that'd be 3 times 4 would be 12 times all that. Only thing that would change.
I like it the other way.
That's fine, you can do it the other way. We're going to do one more, and if I get some good responses from it, then we'll be done, and I'll give you your assignment, and we can chills. All right. Try this one. How's about 2 times, remember, don't touch that 2 until the end, the 5th root of 96 a to the 7th, b to the 14th.
That 2 times 5?
Yeah, it's 2 times the 5th root of. Don't touch that 2 until the very end. 2 times the 5th root of that bad boy.
It'd be 8 times 12.
Try it. I'm going to come around and assist. Let's do the letters first. Actually, it's not. Let's do the numbers first.
I'll work it out with him and then have this conversation.
Okay. How would you factor 96?
Coming down.
32 times
I'm talking to Cody. What?
2 times. I made this up in my head. Can I do that?
Or you could use a calculator.
48,
40,
8.
8. Alright, then we come down 2 and 24. Circle the other 2. And then 2 and 12, 2 and 6, and 2 and 3. Yeah.
I feel like we forgot. Oh, I'm sorry. I left out 12.
Come on, man.
2 and 12. So that became 2 and 6. Okay. Now, what of those numbers occurs 5 times, Cody?
2,
The 2 does. And what number did not occur 5 times?
3. Goes in.
Now, the number is done. We factored it. The 2 occurred 5 times, so we pulled it out. The 3 did not occur 5 times, so we left it in.
How come we just pulled out the 3?
I didn't. I left it in. It's still...
Why use the other numbers? No.
Because we had 5 groups of 2. We had 5 2s, so that's what I needed, 5. So I brought out the 2 because there were 5 of them. The 3 we did not have 5 of. Anything you don't have,
I just
the,
figured it
this...
out in my head,
What
bro.
about like the 24?
A squared.
Hey, hold on a second. What?
What about like the 24 and 12 and stuff?
You only do the prime numbers when you're done. Yeah. That's why I circled them. Every time we came to a prime, I just circled it. That was actually a good idea, Cody.
Hey,
Now,
I got it. I'm sorry.
go.
A squared, b to the 4th. I just did that in my head, bro.
Where does a squared go?
Right up to 3.
What comes out? Now what about the b?
A's a 4.
And what comes out?
B to the. B squared. I got confused.
Now, if you stopped here, you were almost done. Answer yourself. I'm not telling you. The 2 from the beginning comes down. It'll be 2 times that, which will make that actually, what's 2 times 2?
4.
4. So it'll actually make it 4ab squared times the 5th root of 3a squared b to the 4th.
No.
Yeah, I have to cross.
That is the finished product. Cameron, do you have the assignment from the other day?
Okay.
Will you read me the problems that I gave so I make sure I give them the same ones?
The assignment you gave was yesterday?
No, the one you had on Monday.
Was it this?
It should be. They should look just like those.
Is it the 3 problem?
Yeah. What were they?
Hold on, what
Here.
Yeah.
Here, can you hand me that, please? All right. Here are your 3 problems. If you haven't done them yet, hold on. I got it. 3.
You don't even know me. Stop saying my name.
Oh, that says a cube root. the cube root of 50.
You know that.
What?
Then you have,
Is that 50?
yes,
Did you just say he has pictures of
My
my house?
brother.
the cube root.
He does know where I live.
Oh, no, that's the square root, isn't it? Oops, my bad. Hold on a second.
Okay, but thanks for doing it now.
Sorry, I miswrote that.
Really?
Why are you stopping yourself?
That's 3 times the square root, not the cube root. So then there's the cube root of 81. That's why I moved you, so you talk less.
Hey, we're moving in. Well,
Hey, if some people have to talk less, everyone does. Quiet, get to work. Okay, there are your 3 problems.
How about it?